to start this series of lectures or on video so that we are spending our class time working on the different group projects. I'm starting here from chapter 9 and I'm trying to go over some of the things in chapters 9 and 10 that will help us as we work through chapter 18 and get into the graphical user interface. So from chapter 9, there is I'm gonna start here with inner classes and then move on to events and event handling, and then stop by chapter 10 very quickly and then move on to chapter 18. So I'm following the modules and covering all the different sections from the class that we did not cover in the class meeting time. This can be used as a reference for you, and as always, you can go back to the book and review the different chapters in order to prepare yourself for working on the project. So in our classes, so the way this is gonna go is there are things that you can read on your own, and I don't want to spend time on it if you can read it. But I'm gonna try to highlight few things in each one of those presentations, and then towards the end, maybe in a future video, try to summarize what is the takeaway points, and then hopefully maybe give an example or two. You can always ask questions or send me your questions, or come to my office for information. So we learned about classes and we learned about methods, and we said that a class is a unit of code that allow us to represent a concept in our software. Class will have this concept. On every concept that the class represents will have data that describes the attributes of that class, and will have methods or actions or behaviors that the class performs, or responsibilities that the class can take. And we said that when we create a class, we contain methods inside that class, and we contain also variables inside the class as instance variable. We can also have classes inside classes. We can also have classes inside a method. And that's what we define as inner classes. So in the example that you see on the screen, you have a main method, and then you have a class inside a main method. This particular class implements a particular interface called the measurer, which is the chapter 9 has discussed before, and we went over it in the lectures before. Usually you use inner classes when you want to define a concept or represent a concept that is unique, that's a standalone, that is directly related either to the method, and that's why you have an inner class inside the method, or directly related to another class, and that's what you when you have an inner class inside of a class. We follow that a lot in the graphical user interface, as you will see. So if you here is another example of declaring the class inside the class. And the difference is, if you declare a class inside a class, it's available to all the methods of that class. When you look at the files, the build files that comes with an inner class, it will look something like that, referring to the class. Here is the full example with the main method and the class inside of the main method. And here the class is called the rectangle measure, and it implements a specific interface. Usually this is where we would use an inner class when you want to implement a specific feature of an interface, and we said that the interface is a mechanism in code, or a concept that allow us to define rules or contracts that classes will follow. So when you implement an interface, all the methods of the interface, the compiler will force you to implement them, as the case here in this example. And this is some discussion here that you can read. And then I want to jump to events and event sources and event listener. Almost all the graphical user interface or the software that you find on your computer, it's event driven. By event driven, meaning that when you open an application like PowerPoint, the software loads, but what does the software do after that? Actually, the software does nothing until you start clicking on the different buttons or the different icons or the menu items or the menu bar. Only when you click or move your mouse over or you click something on the keyboard that something actually happens and something actually takes place. This is called event driven software or event driven programming, where the software runs when an event takes place or when an event happens. All the graphical user interface software that you will create and the ones you find in your program, they are of that type. What you will see here, and continuing from this chapter here, this discussion, and moving on to chapter 18 and forward, is really a shift in thinking. So far, your program used to run from the main method. So you create some classes and you go to the main method, and it is from the main method that you control how everything will work. In an event-driven software, the main method's job is to launch the graphical user interface. Once you launch the graphical user interface, the events itself is where you put the code or put the procedures that will drive how the software will accomplish the tasks it is supposed to accomplish. So there are three components to think about when you consider building graphical user interface: the event itself, the source of the event, and what we will call the event listener. The event itself is like a mouse move. So here in the example, I'm moving my mouse over a PowerPoint slide, and this is I'm creating an event, and this is a mouse motion event. And as you can see, when the mouse moves on certain areas, it changes shape. If I put the mouse in here, it starts to make some changes. So in response to the mouse clicks and the mouse move and so on, I am generating events. There are different types of events. The different programming languages now, mostly all of them supports the same events, but some may have more events. You are bound with the technology, the programming language you use in the different events that it supports. Operating systems work with the language and the runtime to support that. So every event will have a source, and the source is the component on which the event took place. So in our example here, this is a text box, so this will be the event source, or this slide, that will be the event source, or if there was a button and you click on a button, the button is the event source. The event listener is the kind of the equivalent of the main method. When the event source, we call it fire an event. Like you go to a button and you click on the button. When you click on the button, the button as a source will generate an event. By generating an event, it basically means that the button notifies the runtime environment that an event took place. The runtime environment is then responsible of notifying all the listeners, all the objects that want to know if the event took place. That's what we call the event listener. You will learn how to put all of this together to get your program to work. So the event itself is the action that takes place on the graphical user interface, and the event listener is the object that is notified when the event happens. It's an object that will have methods in it, that will have some code in it, that will be executed and run when the event takes place. For instance, if you want to display a dialog when an icon, when a button is clicked, so you create an event listener, and when the button is clicked, then the method in the event listener will display the dialog that you want to display. And the event source is the component, the graphical user interface component, the checkbox, the option button, the actual button, and there are so many different components, and each one of them can generate one or more different types of events. For example, the J button is a component, and that particular component has generates an event called action event. The way everything is wired together in the Java runtime environment is every component has certain type of events that it is able to generate. Based on that, if you want to listen to a button, the runtime environment or the Java library provide certain interfaces. Remember when we talked about the purpose of an interface is to create some contracts and ground rules. So for every button and every type of event that the Java supports, the library contains an interface that has the contract that you need to follow if you want your object or your class to respond to this particular event. If you want the Java runtime environment to go to your class when a button is clicked, you have to follow the rules of the action event, and these rules are defined in an interface called action listener. The interfaces corresponding to each type of event will follow this name. They will always have listener at the end. So if you go to the Java API documentation and look for interfaces that have listeners in them, you will see all of them. In this particular interface for the action event, there is one method, and this method is called action performed. So what has happening here is that when the user hits the button, the Java runtime environment will look for a class that implements the action listener that is registered with that button. And if there is one, it will call that particular method that is called action performed and pass to it the object that encapsulate the nature of the event as a parameter. So all what you need to do is to override this method and put in it what you want to happen when the user click on the button. So to register a listener, let's say you created a class called the action listener, or a class called the click listener. So you create an object of this class, and then you call on the add action listener method of the button that you created and pass this to it. And this is what we call registering the listener with the event source. And here is an example. This is how in this example in the click listener, what we did in the action performed, or what the author did in the action performed, is to display a method called I was clicked. So this will be a class by itself called the click listener that implements action listener by providing a definition or implementation for the method action performed. Here is a class button viewer that will have a main method that creates a frame, creates a button component on the frame, and add that button to the frame. And here is where we create an object of the action, the click listener class that we created, and add that to the frame, and then set the size, the regular properties that you are all familiar with. Okay. So it is very common to use inner classes for the listeners instead of creating the classes in a separate file. So inside the main method, since the whole purpose of this listener is to provide definition for what should happen for that particular button, you define it as an inner class inside the main method. You don't have to do that. It is usually done if the only purpose is to support that particular button, but you can always have your own. So here is an example where you create the button, and then you have the class add interest listener, implements action listener, provide the action performed, and this is here defined as an inner class in the action in the main method where that button is defined. So here is the full example or the full code for that example, and here is your inner class defined and the method. One thing the inner class helps you with is that it since the inner class is a member of the same method, it have access to the method parameters or the method variables that exist in the method. So you don't have to worry about creating an object and then passing data from the main method to your class or to the object of the class in order to manipulate it. The inner class can get access to it directly. However, the inner class inside a method, to access a variable in the method, it has to be final. So this is like what it will look like, and you can, I believe, read through the rest of this on your own. One of the application of the events is the timer. So this class, a library class javax.swing the timer, it generates equally spaced timer events. What it does, if you set a time and at the end of the time it generates an action event, and you register a listener with it. So if you want to do something at a certain interval, you use this particular class. So you create a listener class that implements the action listener, and which means forces you to implement action performed, and you provide whatever you want to do at the end of every interval. Like you go sometimes to website and says it will refresh every 5 seconds, or you want to do something every 5 seconds, then something. So you create in the main method, you create a listener of this class, you register that listener with the timer object. So if you create a timer, you say new timer, and the constructor receives the interval and the listener, and then you say timer.start, and that will start the timer, and at the end of every interval the listener will be called. So here is an example that displays a rectangle that can be moved. So if you want to display a car that moves around or animate, you can use the timer for that. So here is the rectangle component, and in the rectangle component in the constructor you create a rectangle. In the paint component you draw that rectangle, and then there is a method called the move by, and you give it a delta x and y, and it moves the box or the rectangle by that delta and calls repaint. Repaint is whenever you use repaint, which is a library method, in order to call or force a call to paint component. So whenever you move the graphical user interface, it calls paint component. But if you in your program, like in this case, you want to move the box, so you want to repaint so that it draws the box in the new location, you can call on the repaint method. And here is the main method that creates the frame and defines the rectangle component added to the frame, make the frame visible. Then you create a timer listener, and in the action performed, what you want to do, you move the component, or you call the move by method from the rectangle component and give it interval x, delta x and delta y. And here's we create a listener and add the listener to the timer by a 100 millisecond or 0.1 second, and then you start. And what this will do is, if you run this program, you'll see the car moving one by one. As I mentioned, there are different types of events. The action event is when you click, and it's requires the implementation of the interface action listener. The mouse events, there's different mouse events, 5 of them, and implemented in the, or they are defined in the mouse listener class. There's also, so there's mouse motion. So this is an example of how to use it, which is follows exactly the same thing. And there is a mouse motion listener and different others as well. So this is concludes the two parts of chapter 9, which is the inner classes and then the discussion on events. Thank you.